Hello guys, in this lecture we want to cover differentiation. So we start by defining a derivative. Right, so a derivative or differentiation was introduced to you during the O-level. This is what you called a gradient. So it's developed from a gradient. You remember that a gradient M is change in Y over change in X. Right, so if I draw a line between a curve that cuts the curve at 2 points, and then consider those 2 points. So for example, this point will be equals to X, and if this is the difference between the distance between this point and the next point, so if this is the change in X, so H, this will be the value of X in this point will be X plus H. If this is f of X, and then if I consider the difference or the distance between the Y distance between those 2 points, then this is f of X plus H. Right, now I've got two coordinates, so applying this change in X over change in Y over change in X. So the change in Y, it will be this Y value minus this one, and then the change in X, it will be X plus H minus X, which is this one. So at the denominator then the 2x will cancel out to give you this. So this will be a new representation of our the gradient. So this has got a special name, it's called the derivative. So the derivative is given by dy dx, meaning change in y over change in x. Sorry for this t, it's supposed to be an x, and then this should be the limit as h approaching 0. This means that the differences should be very small. This h should be very small, approaching 0. Then we compute the change in y over change, or this can be represented by f of prime, meaning that the first derivative f of prime of x is the limit of f of x plus h minus f of x over h, as h is approaching 0. So the limits, take note, these are the two most common notations of the derivative. Alright, so uses in environmental science, if you see dn dt, this is the rate of change of population, and then dm dt, mass flow, rate of mass flow change, and then dt, capital T dt, this is rate of temperature change, and then dx dt, this is velocity, and then dp dz, this is pressure gradient, and then ds dx, this is concentration gradient. So those are most common uses of derivatives. All right, so if we are given a function, so for the analytic method, if we are given a function and we are asked to compute the derivative, we have got rules that govern how we compute each one of those derivatives. So rule number 1 is called the constant rule. If you are differentiating a constant, if y is a constant, for example c, all constant will give you a 0. So a derivative of a constant should give you a 0. Number 2, derivative of, as you can see, we are differentiating x with respect to x. So differentiating a constant with respect to x will give you a 0. Differentiating x with respect to x will give you a 1. And then differentiating cu, where c is a constant, is the same as taking the c outside. If you have got the different variables that you are adding, for example u, v, and so on, is the same as distributing the derivative sign. It's called the sum rule. And then the difference rule, likewise, if you have got two functions separating, you can distribute the derivative sign. So the constant rule, so differentiating any constant will give you a 0. For example, a derivative of 17, this is 0. Derivative or 0.150, then what will be the derivative of 10? Need to answer that mentally. Why are we getting a 0 if we are differentiating a constant? Because if you look at a constant line for this one, there is no slope. So for all constants, there is no slope. So the slope is equal to 0. There is no change in the slope. The power rule. So for the power rule, what we do is given by this way: x has got a power n or an exponent n. So you drop the exponent, it multiplies the coefficient of x, in this case it was 1, and then you subtract 1 from the exponent. That's how we find derivatives of the using the power rule. So according to the power rule, if you want to differentiate y is equals to x cubed. So if you are differentiating y is equals to x cubed, it's the same as you drop the power, it multiplies the coefficient of x, and then this will be 3 minus 1, which is equals to 2. So that's how we apply the power rule. More examples for application of the power rule. So if you have got f of x given by 3x to the power 5, so if you want to differentiate this, the derivative f of prime of x will be given by, you drop the power, it multiplies the coefficient, in this case is 3, so this will be 5 times 3, which is 15, and then the power will be reduced by 1, which is 4. Maybe let me do this one. So if you are given f of x is equals to 4 square root of x minus 5, you need to see this and recall that a square root is the same as raising to the power half, laws of indices. And then this one, you drop the power, so it will be 4 times half. 4 times half, it will give you 2, and then half minus 1, it will give you minus half. And then differentiating a constant will give you a 0. So your answer will be f of prime, your derivative will be f of prime minus, which is equals to 2 over square root of x if you apply back the laws of indices. You can pause the video, go through these 2 other examples. Rules for differentiating functions. So the other rule is called the product rule. So if you have got u and v multiplying each other, you can distribute this. First of all, you differentiate v with respect to x while holding u a constant, and then next time you hold v this time and differentiate u. For example, if you have got these 2 functions which are multiplying each other and you want to compute the first derivative of those 2 functions, so it will be, let u be equals to x to the power 3 minus 2, and if you differentiate u, this one, the 3 will drop, it will be a 3, and then the power subtract with 2 minus 2 will give us a 0, it's a constant. And then if your v is equals to 2x plus 4, if you differentiate this, you should see that the power there is 1, so the 1 will drop times 2, it's a 2, and then power 1 minus 1 is a 0, and anything raised to the power 0, it's a 1, laws of indices. If you find this difficult, you can try to go back and refresh the law on what you covered on the laws of indices. Make sure you refresh and memorize those. So therefore, after doing this, we then substitute on this formula. For example, we substitute for x cubed minus 2, and then dv dx we substitute by the derivative of v, which is 2, plus our v in this case is 2x plus 4, times du dx, dx we got 3x squared. So multiplying this by 2, we get this, and then multiplying this bracket by 3x, we get that. And then adding these 2, the 6 plus 2, 8 cubed, plus 12, and then minus 4, just writing it in simpler terms. The quotient rule. The quotient rule is when you want to differentiate two terms which are dividing. The word quotient means dividing functions. So if you want to differentiate functions which are dividing each other, you use this formula. Make sure you master this formula: the product rule, the power rule, the chain rule, and the quotient rule. So for the quotient rule, we have got v du dx minus u dv dx everything over v squared, provided this v is not equals to 0. Right, for example, if you want to find y prime, if you are given y is equals to c minus 2x minus 0.3x cubed, everything over ax squared, we can see in this function there is this one, the numerator divided by the denominator. So you can use this substitution and say let u be equals to c minus 2x minus 0.3x cubed, and let your v be equals to ax squared. If you differentiate your u, if you differentiate c is a constant, it will give you a 0. If you differentiate 2, it will give 2x, it will give you a 2. If you differentiate 0.3 x cubed, the 3 will drop and multiply there, and then minus 1 there, it will be 2. And then this one, the 2 will drop and multiply 2a, and then 2 minus 1, it will give you a 1. And then from there we can apply substitution. For v, we substitute by ax squared, and then for du dx, we substitute by minus 2 minus 0.9x squared. For u, we substitute by u, and then for dv dx, we substitute by dv dx, which is this one, everything over v squared, and we know that v squared is equals to ax squared. Then we simplify this. If we simplify this, this is what we'll get. And then if we simplify these two, starting with this one and this one, common terms collecting like terms, so this one will be a plus 2ax squared, and then followed by this one, only one here, and then minus 0.9 plus 0.6, this is minus 0.3. Right, so this is the solution. You can pause and try to go through the solution to understand. How about the chain rule? The chain rule, for the chain rule, this is a function inside another function. For example, if you have got u, which is given by g of x, and y, which is given by f of u, and remember u is another function. So the composite function of g and f is f of g of x. So in this case, we apply the chain rule where dy dx is given by dy du times du dx. As you can see, the du will cancel, and we still get back to dy dx. So we introduce the chain rule to simplify things and make life easy. For example, if we have got s is equals to t squared minus 2 everything raised to the power minus 3. You can apply the chain rule by because this is a function on another function, which is the exponent. It's a polynomial on an exponent. So you can substitute and say, let this everything inside bracket be your u. So this will be like s is equals to u minus 3 cubed minus 3. And then so your u is the polynomial t squared minus 2. Then ds now in terms of u, ds du, the minus 3 will drop, and then minus 3 minus 1 is minus 4. And then this one, differentiate your u, the 2 will drop, and then 2 minus 1 is 1, and then minus 2 is a constant, so it's 0. Therefore, we substitute this in place of y, we have got s, so this is ds dt, because this is a function of t. So ds dt is equals to ds du times du ds. Right, so ds dt is this guy, and du dt is this one. So you multiply these two. So if you multiply those two, you get minus 6t u to the power minus 4, and then you substitute for u, you get the solution for the chain rule. And then we have got what we call the implicit functions. So these the implicit functions are functions that can be written in both x and y, functions that are difficult to separate x and y, like this given function. In other words, these are nonlinear functions where we've got a product of x and y. Right, so how then do we differentiate implicit functions? So for implicit functions, we differentiate both x and y variables, but whenever we differentiate y, we should include or multiply by dy dx or y prime. Right, let's look at this example. If you are given x squared y minus 2x squared minus xy squared plus x squared plus y squared is equals to 0. So this is an implicit function because the x is multiplying the y squared here and the x squared is multiplying y there. Right, so let's apply implicit differentiation. First, you can see this is a product. For implicit, we need to differentiate for both x and y. But the x and y in this case, they are a product. So we need to apply product rule. We hold this one, we differentiate this one, and hold this one a constant. If we differentiate this one, we get 2x times y. And now we are holding x squared a constant, and then differentiate y. If we differentiate y, we get 1 because it's power 1, drop 1, 1 minus 1 is 0. So y to the power 0 is 1. But remember, we differentiated what? Y. So whenever we differentiate y, we multiply by y prime or dy dx. Now we are done with this one. And then minus x y squared. This is also another implicit part. So we apply product rule. First, hold y squared a constant and differentiate x. If you differentiate x, there is a 1 there. It drops 1 minus 1 is equals to 0. X to the power 0 is 1. And then now hold x as a constant and differentiate the other part. So this will be, the 2 will drop like this, and then 2 minus 1, it's what? It's 1. So your x is a constant, then this is 2x, but remember you differentiated y, so you need to multiply by y prime. Move on, you differentiate 2x, you get x squared, you get 2x. You differentiate 2xy squared, you get 2y. But remember, you differentiated y, so whenever you differentiate y, you multiply by y prime or dy dx. Right, from here you then simplify. You simplify by collecting like terms. If I collect for y prime, it will be x squared to this one. I've got a y prime here which is 2xy, this one, but this one is negative. And then I've got a y prime here which is 2y. So these are my term coefficient of y prime. And then what remains is 2xy, this one, minus y squared, which is this one, and then plus 2x, which is this one, and this is equals to 0, making y prime the substitute of the formula. I'll get this guy. So that's how we apply implicit differentiation. Alright, here comes another interesting type of differentiation of logarithms or natural logarithms. So if you are given a logarithm or a natural logarithm with a function there or an angle as f of x, for you to differentiate for y, you need to find the f of prime of x the derivative of the angle over that f of x. So when you're differentiating logarithms, it's f of prime of x over f of x. So if y is equals to lim x squared minus x, should see this as your function f of x. Therefore, you let f of x be equals to x squared minus ax. If you differentiate this to get your first derivative, you obtain 2x minus a, and then you substitute so that you get the overall derivative of your logarithm, which is given by f prime of x over f of x. You already have these two. F prime of x is 2x minus x over f of x, which is x squared minus a x. And then for exponential functions, so for exponential functions, we apply the chain rule. So for exponential functions, we apply the chain rule. How do we apply the chain rule? This exponent, this power, we let this power be equals to u. So this will be u is equals to ax. What is on top there? We substitute by u, such that this will be y is equals to u e to the u. If I differentiate e, it doesn't change with respect to u. So dy du of e is the same, right? Therefore, the formula of the chain rule is this: dy dx is given by dy du dx. Right, so for this example, if you are given y is equals to ex squared minus ax, you want to differentiate this. First thing is you substitute for u in your power there, so your u will be x squared minus ax. If you differentiate your u, you get du dx, which is 2x minus a. Right, remember, if you are differentiating dy du doesn't change, it's still e to the u. Applying the chain rule, dy du is e to the u, which is e to the u, times du dx, which is 2x minus 1. So this gives me 2x minus 1 to the power x squared minus ax if I substitute for my u. So thank you. Next time we'll look at application.